The rapid influx in the acidification of the ocean is a direct threat to the oyster industry in Willapa Bay, Washington. The rise in acidity prevents the oysters and other shellfish from adequately building their shells, which is a necessary process in order to grow. The rise in acidity can be directly attributed to an increase in anthropogenic emissions, particularly since the beginning of the Industrial Revolution. About a third of the CO2 in our atmosphere gets absorbed by the oceans, at which point it reacts with the water, forming carbonic acid. The carbonic acid lowers the pH, thereby affecting the carbonate ions that shellfish rely on for their shells. Oftentimes, this already dire situation is exacerbated by pollution and runoff, causing eutrophication and hypoxia in some cases. Generally speaking, oceanic waters in the high latitudes are going to be more susceptible to acidification due to their geographic location as it relates to anthropogenic emissions. What makes Willapa Bay extremely susceptible to acidification is due to the upwelling caused by winds pushing water away from the coast. The deeper water, which is already rich in carbon and other nutrients, pairs up with even more carbon-rich water, causing the water to be even more corrosive. As mentioned before, the acidity of our oceans has increased since the Industrial Revolution, by 30% to be exact. That said, the current estimate is that this could increase by about 150% by 2100 under the A2 scenario that we are on. The oyster industry within Willapa Bay is already suffering and will continue to suffer for the foreseeable future, which will negatively affect this multi-billion-dollar industry. Coastal towns that rely on its economic benefits will ultimately suffer in the long run if nothing is done. Optimistically speaking, there are multiple approaches to tackling this problem. However, the only form of action that can be leveraged to promote absolute resolution is by acting on sustainable energy solutions, stricter code enforcement, and better infrastructure to prevent runoff.